Now, so this we are doing chapter number 5 HL of the lattice enthalpy and the solution enthalpy, right? What are the factors affecting it? What do you mean by lattice enthalpy? Lattice enthalpy is nothing but it is the enthalpy change when 1 mole of the ionic solid is broken apart, right, into its constituent gaseous ions, right, isn't it? So this is very crucial for us to understand, right? What is lattice enthalpy? Lattice enthalpy is the enthalpy when 1 mole of the ionic solid is broken down into its constituent gaseous ions, right, isn't it? Constituent gaseous ions. So this is very crucial for us to understand that whenever we speak about lattice enthalpy, now write down this. Lattice enthalpy is breaking the ionic bond. Write down, right? Just important information you have to know. Lattice enthalpy is what? Lattice enthalpy is breaking down the ionic bond, right? What do you mean by bond enthalpy? Bond enthalpy is breaking covalent bond. Please have a clear-cut idea about this. Celia, is it clear? Okay, is it clear? Kavya? Lattice enthalpy is breaking an ionic bond. What is bond enthalpy? Bond enthalpy is breaking a covalent bond, right? Make sure that you know this, right? Lattice enthalpy is breaking an ionic bond. Bond enthalpy is breaking a covalent bond, right? Isn't it? Fine. Now if you're seeing an ionic compound, right? If you're seeing ionic compound, in an ionic compound, we have to see that the ions are in a lattice, right? A lattice structure, a gigantic lattice structure, right? We have to give our heat to separate them, right? Separate these two ions, right? Separate these two ions. And we are getting what? We are getting an endothermic value. Lattice enthalpy is endothermic. What's the equation? Practice the equation I'm telling you. This will be needing in the Born-Haber cycle. What's the equation? We have to search on where is 1 mole. 1 mole is where? 1 mole is here, right? 1 mole of the ionic compound is broken apart. 1 mole is here, right? 1 mole of the ionic compound is broken down into its gaseous ions. Okay, we are getting this, right? Now coming to this next part, if you see, whenever we are breaking down an ionic compound, right? 1 mole of the ionic compound is broken down, right? Now, on what factors does the lattice enthalpy depend upon, right? Isn't it? Lattice enthalpy depend upon. We have to know that lattice enthalpy will be depending upon 2 factors, right? Now, K, can you just judge? Can you tell me that what factors will be the lattice enthalpy depending upon? Can you tell me one factor? K, tell me.
Charge of the ion.
Charge of the ion. Suppose you're having Na plus Cl minus term. Now, Celia, if you're having Mg2 plus O2 minus, right? Now, can you tell me? Tell me, Celia, that where will be lattice enthalpy more? In NaCl or in Mg2 plus and O minus? Can you tell me where will be lattice enthalpy more? Celia?
O2 minus.
O2 minus. You're saying, Kavya, what's your take? What's your take? MgO or NaCl? Where will you know more? Kavya? Kavya?
Oh.
Where will be? It depends upon the charge of the ion, as K said, right? Charge of the ion, right? Now write down this. If the charge of the ion is higher, the lattice enthalpy is higher. Write down, right? Is it clear? Fine. Lattice enthalpy directly proportional to the charge of the ion, right? Fine. Is it clear? So MgO will be having a larger, that is much larger lattice enthalpy, right? See, plus 771. And Mg is having what? Plus 3791. It actually exponentially increases, right? Not directly proportional, exponentially increases, right? Isn't it? So this is a very important part. We know that if you're seeing that whenever we are seeing the lattice enthalpy, right? That whenever we are seeing that it will be depending upon the charge of the ion, right? Higher the charge of the ion, the lattice enthalpy will be more. Is it clear? So this is very important. First. Second is what? It will be depending upon what? The size of the ion, right? Now how does it relate it, right? Now we have to know that that the ion, if you see, now if you see that we are having a unit positive charge in a larger ion, and you are having the unit positive charge in a smaller ion, right? Isn't it? Smaller ion, right? Isn't it? You are having a unit positive charge in a larger ion. We are having a positive charge in a smaller ion, A and B. Now, Kavya, can you tell me that where will be the charge concentration more, in A or B? Did you understand the question? We are having the same unit positive charge in a larger radius, spread it across a larger radius, and a unit positive charge spread it across a smaller radius. Now, can you tell me, Kavya, that where will be the concentration of the positive charge more, in A or B? In B, you are saying this is Kavya. And what about you? Can you tell me K? Where will be the more?
A.
K, did you hear my question? A unit positive charge, 1 unit positive charge is spread around a larger area. Larger area. You're taking the same unit positive charge and you're putting it into smaller area. Where will be the constant of the charge more? And why? You said A, right?
No,
Why? Can you tell
said
me?
B. I said B.
Oh, you said B. I'm sorry. I'm sorry. Sorry. I know. I don't know whether the question answer is correct or not. Celia, what's your take? Celia?
B.
B, isn't it? Very good. Is it clear? So we can tell that if the charge of the ion is smaller, the lattice enthalpy will be more. We need greater amount of force to break it, right? Is it clear to you? Now tell me one thing, Celia. If you're going from lithium, sodium, potassium, rubidium, top to bottom in a group, what happens? What happens? The atomic radius increases or atomic radius decreases? First tell me. The atomic radius increases or atomic radius decreases? Can you tell me, K? When you go from lithium, what happens? Lithium is 2,1, right? Lithium is 2,1, right? And sodium is what? 2,8,1. So if you go from top to bottom, K, the atomic radius decreases or atomic radius increases? Okay, increases, right? If you go from top to bottom, atomic radius increases, right? So you are seeing that whenever we are going from lithium plus, Na plus, K plus, or Rb plus, the atomic radius increases, right? Isn't it? So if you're going from sodium to cesium, see, we're going from sodium to cesium, right? See, the lattice enthalpy decreases because what? Because the radius of the ion increases. Can you see this? Sodium is 95 and cesium is 161, 169. So we are seeing that whenever we are seeing the lattice enthalpy will be depending upon what? The charge of the ions, directly proportional, exponentially proportional, you can tell, not directly proportional, exponential proportion, and it will be inversely proportional to the size of the ion, right? We know this, right? Now come to the part called as what? Come to the part called as see the size of the ion, the lattice enthalpy will be larger when for the smaller ions, right? And the lattice enthalpy will be higher for more charge. So obviously +2 ion into +2 ion -2 will be having more lattice enthalpy than +1 -2 and +1 -1, right? Did it? This is the thing we are seeing, right? Now come to the part called as what? Come to the part called as the part called solution enthalpy, right? Now, what do you mean by solution enthalpy, right? What do you mean by solution enthalpy? I'm telling you guys that you have to just memorize the equations, right? And the definitions. This is very important. What do you mean by solution enthalpy? Solution enthalpy is what the equation also we have to know. We have to very well know that what is the equation. The equation of the solution enthalpy is that if you're taking 1 mole of the ionic compound, what is solution enthalpy? The solution enthalpy is that it is the enthalpy change, right? It is the enthalpy change. When 1 mole of the ionic solid, right? It is the enthalpy change. When 1 mole of the ionic solid, right? 1 mole of the ionic solid is dissolved in excess water, right? Dissolved in excess water to get a infinite dilution. Is it clear? Infinite dilution, right? What is enthalpy of solution? Enthalpy of solution is the enthalpy change when 1 mole of the ionic compound, right? 1 mole of the ionic compound is dissolved in excess water. Excess water you have to have, right? We have to ensure that all the ionic compound is totally soluble. Why excess water? You might be thinking. We have to ensure that all the ionic compound has to be totally soluble, right? In excess water, in infinite dilution solution, right? We have to ensure infinite dilution, right? So now going to this thing, now we have to see that when we are seeing, when this is chapter number 4 SL, we have to touch a little bit, right? Whenever we are taking an ionic solid, right? Ionic solid, what happens? How does the solubility come into the steps? Now see, now if you're seeing an ionic solid, right? If you're seeing ionic solid, when we dissolve the ionic solid, right? When we dissolve the ionic solid into water, water does what? Water will be acting like a god. How? Water will be doing what first? Water will be first separating these two ions separately, right? Is it clear? What does water do? 2 steps are there. Please write this down. Dissolving of ionic solid will be a 2-step, right? First step is what? When you dissolve any ionic solid into water, water does what? Water will be pulling these two ions, right? First, right? Pulling these two ions. First step is what? Water will be pulling these two ions and separating them into gas ions, right? This. Is it clear to you till over here? Celia? K, did you get this thing? Kavya, did you get this thing? Celia, did you get this thing? First step is what? We are dissolving an ionic compound into water, right? Water will be first separating these two ions into gaseous ions, right? Na plus gas and Cl minus gas, right? It will be pulling and separating these two into gaseous ions first. Then this is the first step, right? First step. Now, can Kate tell me one thing? That have you seen an equation like this earlier? NaCl solid, how much will be the enthalpy? Can you tell me what will be the enthalpy similar to? Okay. Okay. Have you seen this equation earlier?
Yeah.
Just we did some moments earlier, right? That 1 mole of ionic compound is broken down into gaseous ions. So this energy will be needing how much? Celia, can you guide me? How much approximately energy will be actually needed? Approximately equal to the lattice enthalpy, right? Isn't it? The same energy will be needed by water. See, water acts as like a god. Can you see this? If you want to separate out NaCl into its constituent ions, how much temperature do humans need? 800 degrees centigrade, right? 800 degrees centigrade, right? But see, water acts like a god, right? This water is separating out the two ions. How much energy it needs? Approximately equal to the lattice enthalpy. Celia, did you get this thing clearly? Celia, what is the lattice enthalpy? Kavya, did you get this thing? 1 mole of the ionic compound is broken down into gaseous ions. See this step, right? Okay. Now after this, what happens? K, did you understand this part? K, did you understand any questions? Please ask me. K, did you understand this part?
Yes.
First part,
Yes.
water. You did. Okay. Celia, did you get it? Celia, tell me.
Yes.
Yes. Kavya, did you get this thing? Kavya.
Yes, sir, got it.
Thank you so much, Kavya. Kavya, you are joining very late. I know from Delhi, right? Very late. I know. Thank you so much. Thank you so much. Thank you so much. Please stop me. Please stop me. I'm there, right? Please to stop me that, hey, I didn't understand. Please tell me. First tip is what? Water will be dragging the two ions separately. Okay. And separating them into gaseous ions. Can water job be finished now? No. Water job is not finished. Because if water leaves them after separating, these two ions will be attracting each other and going to NaCl back again. So water does what? Second step. Water has to surround the individual ions, surround it like this, so that the Na plus and Cl minus does not combine back again, right? Is it clear? Did you get this thing? Does not combine back again. This is the second step, right? This water does this, right? It surrounds them quickly so that the individual Na plus and Cl minus does not combine back again. This first step is similar to the lattice enthalpy. Same energy, right? Same energy is needed by water to separate down. The second step is called as what? Any guesses? Kavya, can you tell me what the second step is called as? Hydration enthalpy, right? Write down. Isn't it? Hydration enthalpy. HYD. Is it clear? Celia, can you tell me the steps which I told you how water separates them? Tell Celia, please describe in your own words. Celia? Hello?
Yeah.
Celia, tell me the steps. When you put an ionic compound into water, what's the first step? What's the first step which does? Water does what?
Lattice oh. It
First step
breaks.
is what? It first separates the individual ions into gaseous ions. Is it clear?
Yeah.
How much energy will it need? Approximately equal to the lattice
Lattice.
enthalpy, right? Lattice enthalpy. Now what is the step K? What is the next step? When it's separated out. There's a threat that if water leaves them idle, they will be again combining back. Right? Water job is not finished. What is the second step, K? Tell me. K, what is the second step? K, can you hear me?
I can hear you.
Second step is what? Water does what? Water surrounds the individual ions. Is it clear? Fine. Did you get this thing?
Yeah.
Did you get this thing? Water surrounds the individual ions, right? Like this, right? Like this. Water surrounds the individual ions, right? Like this. So that they do not recombine back again, right? Is it clear? This process is called as what? Hydration enthalpy. K, is it clear? Celia, did you get the second step? Second step, did you get this thing? Celia, come back. I'll be just asking everybody. Celia, is it clear?
Yeah.
What is the
Yes.
second step? Kavya, did you get this thing? What is the second step? Okay, did you
Yes.
understand what is the second step? Water surrounds them
Yes.
quickly surrounds them so that they cannot recombine. This second step is called as hydration enthalpy, right? Isn't it? Hydration enthalpy. Did you guys see? So this is very important that whenever we are seeing when we put an ionic compound into water, right? What happens? We are getting a equation like this, right? That NaCl we write like this, right? NaCl solution enthalpy we write what? Enthalpy of solution we write like this, right? Na plus Aq, right? Okay, I forgot to tell you this. Wait. Let me tell you this. Do you know? No. Do you know how this diagram is actually written in the states of matter? Okay, can you guess how this is actually written in the states of matter? Can anybody tell, Kavya, how this is written in the states of matter? Na plus Aq. Brilliant. Celia, is it clear? This is written as Cl minus Aq, right? Is it clear to you what is Aq? Water has
Yes.
surrounded the ions. Aq means this in the deeper sense, right? So now see, I'm coming back to the enthalpy of the solution. Enthalpy of solution is what? Enthalpy of solution is the enthalpy change when 1 mole of the ionic compound is dissolved in excess water to get an infinite dilution, right? So obviously, we see that the enthalpy of particular solution will be something like this, right here. But we know that, is it a single step reaction? No, this is not a single step reaction, right? We learned this. First step is what? First step is water separate them into gaseous ions. That is exactly equal to the lattice enthalpy, right? Next step is what? Next step is that now better to write down in these two lines, right? Next step is what? That sodium ion will be surrounded by water. This is delta H hydration of Na plus, right? Isn't it? And Cl minus ions will be also surrounded by water. This is delta H hydration of Cl minus, right? This is hydration enthalpy. So we have to know that what is the definition of hydration enthalpy, right? Hydration enthalpy is the enthalpy change. What is the hydration enthalpy equation? Na plus gas will be equal to Na plus Aq, right? Surrounding it, right? Water surrounds this quickly, right? So that they can recombine it back, right? So enthalpy change when 1 mole of the gaseous ions, right? 1 mole of gaseous ions is surrounded by water molecules, right? To form an infinite dilute solution under standard conditions, right? Is it clear? So can you read this particular definition? Celia, can you read the question? Read the definition for the hydration enthalpy. Read it loudly, Celia. Celia,
Yeah.
read this loudly.
Enthalpy change of hydration is defined as the enthalpy change when 1 mole of gaseous ions is surrounded by water molecules to form an infinitely dilute solution under standard conditions.
Brilliant. And enthalpy of hydration is always negative. Write down this, right? Always negative, right? Isn't it? Always negative. It releases energy. Is it clear? My steps, right? Isn't it? So this is very important that now we have to understand that whenever we are having a equation like this, right? Isn't it? So now we have to apply Hess's law, right? Now to apply the Hess's law. If you want to find out the enthalpy of solution, right? What is Hess's law? Hess's law says that for any enthalpy of reaction, right? If you want to go to this, right? We can go via indirect means also, indirect way also, this, right? Fine, over here like this, right? We can also go like this, right? So if you want to see the enthalpy of solution, if you want to calculate, we are having the lattice enthalpy, right? And we have got the hydration enthalpy also, right? Isn't it? So if we want to write down the enthalpy of enthalpy of solution will be equal to what? Enthalpy of solution, you can also go via indirect means, right? This Hess's law, right? We are applying. Now, this arrow and this arrow is on the same side. Celia, same side? Yes. So you write for delta H lattice, right? Isn't it? Now, this arrow and this arrow in the same side? Yes. So plus delta H hydration Na plus delta H hydration Cl minus, right? Isn't it? So delta H lattice enthalpy is known. We can know this lattice enthalpy. We can know the hydration enthalpy also, right? Now my question to you is that now write down this. Enthalpy of solution should be negative actually, right? Should be negative for a spontaneous solution to be happening, right? Isn't it? Now we all know a very important thing that this lattice enthalpy, right? This lattice enthalpy is very, very high, right? Lattice enthalpy is very high, right? We have seen the lattice enthalpy data also. See, I'm coming back to this page again. Lattice enthalpy, if you see, is very high, right? See, it's a very high endothermic value, right? Because we are having an ionic lattice, right? We are separating. See, plus 2526, plus 3791, right? Lattice enthalpy, right? So ultimately, we are getting what? Ultimately, we are trying to get that. If you're seeing that, whenever we are trying to see this see this equation, right? Right? We can write what? The delta H solution will be equal to delta H lattice plus first bracket delta H hydration plus delta H hydration of Cl minus and Na plus, right? And this, right? So this is very important that whenever we are seeing that this lattice enthalpy is positive, right? Lattice enthalpy is positive, right? Positive. Now, in order to make the delta H solution negative, right? This hydration enthalpy should be more negative and surpass this positive value, right? Isn't it? To make this delta H solution negative, right? Is it clear? So ultimately what happens? Ultimately we are seeing that the delta H hydration is exothermic. It should surpass, right? It should surpass. Now if you see the sodium chloride, right? If you see the sodium chloride is slightly endothermic, right? See the hydration enthalpy, you are seeing what is negative, right? It should surpass the enthalpy of lattice enthalpy, which is positive, right? So this is the way we do, right? Now coming to this thing. Now, if you see that whenever we are uttering the word enthalpy of cell or enthalpy of hydration, always remember to you that where is 1 mole given in the equation. This is very important. Where is 1 mole? 1 mole you have to search. Where is 1 mole? 1 mole you cannot change over here, right? You have to see that where is 1 mole over here, and you do not change 1 mole. 1 mole of the gaseous ions is surrounded by water molecules to form an infinite dilute solution. Now come to the part called as, if you see, just try to cover this portion from the Steve Owen book today. I'm telling you, lots of important, important definitions is there, important equations is there, right? Study from over here. Now we have to understand that what does it depend upon, right? Enthalpy of hydration depends upon what, right? Same thing, right? Now tell me one thing, Celia. Suppose we are taking a Mg2 plus, right? Mg2 plus, and water is surrounding them, right? Water is surrounding. How is water surrounding it? Water contains a dipole, delta minus delta plus, right? So water contains a dipole, right? Delta minus delta plus, right? So water will be surrounding them. Now my question to Celia is that if water surrounds Mg2 plus and it surrounds suppose Na plus, right? Mg2 plus, the charge is double. Can you tell me that hydration enthalpy should be more exothermic where? Celia? The hydration enthalpy will be more where? Means exothermic, right? More, it's bond formation, right? There's a formation of bond which is happening, right? Intermolecular force of attraction is formed, right? If the charge is higher, right? If the charge is higher, what is your take? The enthalpy of hydration will be more exothermic or less exothermic? I didn't teach you, but can you just tell me what do you take? The enthalpy of hydration will be depending upon the charge, right?
So
now write down, if the just take a guess. If the charge is double, see, so the enthalpy of hydration will be more or less? Means more exothermic, you are saying. Kavya, what is your take? Charge, same thing as lattice enthalpy. See, same thing as lattice enthalpy. Lattice enthalpy, the charge, if it's higher, the lattice enthalpy is more. Similarly, hydration enthalpy is what? If the charge is higher, the lattice enthalpy will be higher. Is it clear? Fine. Got it? And what happens? The hydration enthalpy depending upon the ionic size, right? Size of the ion, right? Now can you tell me, Celia, the size of the ion, if the size of the positive charge is longer, right? Means more radius, the positive ion is smaller radius, where will the hydration enthalpy more? In A or B? What is your take? Same as lattice enthalpy. Tell me. B you are saying, Celia. What about you, K? Where will the lattice enthalpy more? Huh? Sorry, hydration enthalpy. B you are saying, right? K is saying B. Kavya, what's your take?
B.
B. Brilliant answer. See, everybody is brilliant. See, clear to you? See, now if you go from lithium to sodium, the size increases. See, the hydration enthalpy is less exothermic, right? Isn't it? Now see, if you're going from sodium to double the charge, almost similar size. See, the hydration enthalpy jumps, right? Did you get this thing? Same as lattice enthalpy, right? So this is very crucial part, right? So we have to know that whenever we are seeing this, right, we can understand that the hydration enthalpy should be more exothermic. We know why. Because we are seeing that the equation is what? The equation is this, right? See, the lattice enthalpy should be with always positive, right? This hydration enthalpy should be more negative in order to surpass the positive value, right? Making it more negative, right? Isn't it? So this is the portion of what? This is the portion of the hydration enthalpy, right? Now, there's a important thing. See, now if I draw MgCl2, right? MgCl2, suppose MgCl2, the enthalpy of solution. So here, see, we have to do what? We have to take this, or shall I do as a homework, right? Send me a message, please. Okay. Sorry, Basilia, send me a message, please. Delta H solution, right? Solution enthalpy of MgCl2, right? So I'm just guiding you once. See, it as a homework you have to do. Delta H solution will be what? Mg2 plus AQ, Mg2 plus AQ plus 2Cl minus AQ, right? Isn't it clear? Fine. See, I'm just construct. This is enthalpy of solution. How to find out? We draw lattice enthalpy. This is what? This is delta H lattice enthalpy, right? Means if broken down the ions, Mg plus 2 plus 2Cl minus, right? Isn't it? This, right? This is a lattice enthalpy, right? Now, hydration enthalpy comes after this. See, we are joining the arrow. See, this is what? This is delta H hydration enthalpy of Mg2 plus, right? And Cl minus, how many Cl minus are there? 2 Cl minus, remember, right? Isn't it? This is the trick you have to follow, right? When 1 mole of the ionic substance is surrounded by water, now see 2 moles are there. So this will be 2 into, just this trick you have to understand, right? Delta H hydration of Cl minus, right? This trick you have to understand. Bus, that's all, right? So if you are connecting the Hess's law, how do you connect? We connect like this, right? We connect the Hess's law like this, right? We are going from here to here. So delta H solution, right? We write like this. K, can you write down this thing? What will the equation? K, can you write down this? K, can you write down the equation? K, can you try to write down the equation? K is here. Celia, yeah. Please, Celia is here. Kavya, can you write down the equation? Or you can do what? K, you take over here. Celia, you take over here. Celia, try to write down. Try to write down the equation. Kavya, you try to write down over here. K, please tell me what are the challenges you're having. Tell me. I'm telling you that what is the delta H solution equation you have to write. Tell me, K. Celia, write down. Kavya. K. K, where is struggling? Celia, tell me. Celia, can you hear me?
Yeah.
Hello?
Yeah.
Delta H solution, right?
Mhm.
This is the thing we are going, right? That will be what? You can go to the alternative path, right? Like this we can go, right? Isn't it? Like this. See arrowhead, see? This arrowhead like this, right? So delta H lattice, write down, Celia, write down delta H solution will be equal to delta H lattice. Kavya, please try. I'm there, right? Kavya, please connect, please. Kavya, hello. Delta H solution is equal to what? Kavya, see the arrowhead are what? Same side, right? So all will be plus added, right? Equal to delta H hydration of what? K, Mg2 plus, right? Mg2 plus, hydration of Mg2 plus, plus, this is a bracket you have to write, bracket, first bracket. Delta H hydration of Mg2 plus. Celia, where are you struggling? Please tell me. Kavya, what happened? Kavya, what happened? Kavya, write down.
So my pen isn't graphing, understand.
Okay, no worries. Delta H hydration of Mg2 plus how many? 2 moles of Cl minus. See? Okay, 2 moles, right? So we multiply this by 2, right? Isn't it? Plus 2 moles of Cl minus. See? isn't it? Hydration of Cl minus, is it clear? How much? How much? How much? Can you guide me, Celia? 2 Cl minus is there. Yeah, multiply by 2. Yeah, you're fine. Why did you rub that? Hydration of Cl minus. Did you get this thing?
No, because I put 2, but you put 2 in front.
Oh, okay, no worries, no worries. Is it clear? Are you getting the Hess's law we are applying, right? Hess's law. See the arrowhead? Arrowhead is going in this direction. So we add it. See, arrowhead over here is this. So we add it, right? Add it, right? We add these two, right? And this is a trick you have to understand in the boards. This thing of the boards exams, right? This thing you have to understand, right? Isn't it? Fine. So this is what this was all about. What this was all about, the enthalpy of the solution, right? Now going to this thing now over here. Now see, now what I'm doing, I'm just